Hey team, it's Mr. Z, and we're going to continue our adventure creating functions with specific attributes. And we're going to connect all of the information from standard form, factored form, and vertex form. All right, let's finish this lap and call it a day. All right, so again, it wants you to write a quadratic, and the requested name for this is h of x. It needs to be concave down, and it needs to have a y-intercept at 0, 2. So we need to write something that is concave down and it has a y-intercept of 0, 2. This y-intercept at 0, 2 is going to tell me I need it to be in standard form, and I also can draw the conclusion that c is 2. I know that a has to be a negative number. So let's go ahead and dive in. Let's see what I can fill out. So I need to create something that's h of x. It needs to be a negative a value. I'm going to just use negative 1 x squared plus bx plus 2. Notice how I just used any number for a? That is going to be the case for b. I'm going to choose a positive number because I like it to be simple. Positive 3x. So this is going to be a concave down quadratic that has a y-intercept of 2. Boom. Notice how there was flexibility. I had a big chunk of information. I knew what type of number A had to be. I knew that B was going to be a number in there, but notice how I didn't have any guidance and it was okay for me to plug whatever number. But there are specific parts that had to be negative. And also C had to be 2. No discussion. All right, for this last one, I want to tease about the future. We're going to continue to read. We want a quadratic function. I want it to be called k of x, aka, so I know which one is which. It needs to be concave up. It is going to be a vertical stretch. And this doozy, an axis of symmetry of x of 3. Okay, creating this axis of symmetry, let's talk about this. This guy is going to be concave up and it's going to be stretched. Since it is concave up, we know that it is going to have a vertex that is a minimum. One trait about quadratics is that if I draw an axis of symmetry going vertically, it will perfectly cut the quadratic in half. So essentially what this is saying is that the axis of symmetry is at x equals 3, aka on the coordinate plane, the line at 3 is going to be a vertical axis. What it also references, notice how it goes through the vertex. Remember, the vertex is the HK. The x part of this vertex is 3. So we have to keep this in mind as we create our equation. So let's write this out. This is going to be in vertex form, and that's because they gave me a piece of information about the vertex. This is the h coordinate. So I'm going to go ahead and reference above until I have this by heart. A x minus h squared plus k. I'm going to go ahead and use k of x equals a times x minus h squared plus k. Let me go ahead and plug in some stuff. I know that a is positive. Now I have to keep track of a vertical stretch. Stretch means bigger. I'm going to make something bigger. I'm going to make something twice as big. Now, let's continue. X minus what is h? Well, they're telling me it is going to be 3. And then it needs to plus k. Since I need to just write a generic quadratic function, they didn't specify what k needed to be. So let me plug in a value of 1. So I'm going to just rewrite this to be k of x is equal to 2, x minus 3. Notice how I added that exponent in. And let me have k be 1. Voila. I wrote a quadratic function that is concave up. It is being vertically stretched by 2, and it has an axis of symmetry of 3. They didn't specify what the k needed to be, so I picked a nice simple integer. All right, that's it. Go ahead and try the homework and see how well do you fare on your own. Good luck.